Welcome to a lesson on function graphing. We're going to be talking about, when we talk about function graphing, I know you guys have done graphing in the past, but maybe perhaps not in a function format. Regardless, it's very similar. I don't want you guys to freak out about this f of x. It is the same thing as y, but let's say we're going to graph this with just a very restrictive domain. And what this means is I just want us to graph this equation on this graph using the x values of -4, -2, 0, and 2. And there's a lot of ways you can organize this. My way of doing this is creating a nice little table with all my x values, which will result in these f of x or y values, and have some nice work in the middle. And the way we find out the matching y values is I'm going to take my function right here, f of x equals 2x, and I'm going to take every single x value and just put them in one at a time. So for this one, I'm going to do f of -4. That means I'm going to replace the x with -4 right here. So we have 2 times -4, which is -8, and that goes right there. So for the next one, I'll find f of -2, which is 2 times -2, which is equal to -4, and that's our y value. How about f of 0? Well, that's just going to be 2 times 0, just like 2 times x, 2 times x. 2 times 0 is 0, so our matching value is 0. Okay, we start with 0, end with 0, that's fine. And then we have f of 2, because we start off at 2 right here, which is going to be 2 times 2, which will be 4. Now we have all our x values and their matching y values. See that? So now I'm going to graph this. So -4, -8, it's going to be, well, here's -4, -8 right there. Then we have -2, -4. So the x value is -2, which is right here. And I go down to -4. 0, 0, which is right in the middle. And finally, we have 2, 4. So I'm going to go 2 over here and 4 up. And that's how you graph this if you're given a specific domain. But what if you weren't given the values? What if instead you're just asked to, if I was going to get rid of all this, you weren't? Well, the thing is, guys, the first thing you should do to graph any function is to do what I just did right here anyways. Just pick a few x values until you have a general shape. And we can see that this is going to be very clearly a straight line. So if you weren't given a specific domain, what you're going to do is you're going to connect all the dots with a single line and draw arrows at the end of the graph. Now, each equation, there are actually different types of functions, right? In fact, some of you should know what this is. It's a linear function. Notice I drew my line with my arrows. And there are different functions with different shapes. We're not going to specifically talk about the different functions yet. What you want to develop today is the skill of just picking some x values if you're not given them, and to put them on the graph and then connect all the dots and create the general shape of the function. Or in another case, you might be given specific x values that we did earlier, like here, and just graph them individually. Now, there's one other situation I want to show you guys, and that is, what if we're given this situation? How is this different than the equation over there? So some of you are probably already thinking there's no f of x, which is correct. And remember, f of x is y, so that's the same thing, but there's something else that's different. And that is, the y value and the x value are together on the same side. We have been graphing so that this is set up as f of x equals 2x or y equals 2x, because this is easy to deal with, right? Because we just put x values into there and out pops the matching y values. It's a bit harder in this format, unfortunately. So what we're going to do is we're actually going to solve for y. Remember, that means we're going to set everything up so y is by itself. So to do that, our first step is to take the equation and get rid of x. I want to move x to the other side. So if this is a normal x right here, I'm just going to subtract x on both sides, because that will cancel out with the positive x. So we get 3y equals 15 minus x. Now, we're actually kind of used to seeing it more like this, so I'd recommend swapping the 15 and the minus x, so the minus x, the negative x is in the front, and we have a positive 15 to the right. Now that we have that done, notice we still haven't solved for y because y is not by itself. There's a 3 there. And what that 3 is doing is it's multiplying. So the opposite of times 3 is divide by 3. And the whole reason we did that is so we can cancel it out. But watch what happens on the right side, guys. We are dividing everything by 3. So that's y equals negative x plus 15 over 3. And if I want to simplify this more, I could split this up so it looks more like this, where each term is being divided by a 3. Now, there's nothing I can really do with this, right? But I could do 15 divided by 3. Remember, a fraction is the same thing as division. 15 divided by 3 is 5, and boom, look at this. Way easier to deal with now than we had over there. So, now that we have our y equals, we can graph it on this domain that they gave us. The domain is 0, 3, 6, 9. So I'm going to create my table of 0, 3, 6, 9, and I'm going to start graphing this. So I have y equals negative x over 3 plus 5, but I'll replace the x with a 0, and negative 0 divided by 3, that's just going to be 0. 0 plus 5 is 5. So I'll put a 5 right there. Now I'm going to put 3 in there. Negative 3 divided by 3 is negative 1 plus 5 is 4. So we have a 4 right there. Now we have 6. So let's put in 6 into the equation. It becomes a negative 6. And we divide that by 3. That's going to be a negative 2. Negative 2 plus 5 is 3 right there. And then finally, we put in 9. It becomes a negative 9. Divided by 3 is negative 3. We add 5, and that's 2. So our final point is 2. And now that we've done this, we have all the matching x values and y values, and we can graph them like this. Notice once again, it's just a bunch of dots because they gave us a specific domain. We're not connecting them because they gave us the domain. And that is actually it for the lesson. So if you have any questions, feel free to email me or ask me in class. Otherwise, make sure you all do your homework. Have a good day. Bye.